Hi, this is King of Review. Find the sum of the geometric sequence 2, 4, 8, 16, and the sequence continues until the last term, which is 1024. So we're dealing with a geometric sequence. A geometric sequence is a sequence or list of numbers or terms where the ratio of any term to the previous term is constant. So each of these numbers here is a different term. This first number here, this is the first term, so we call it A1. The second term is called A2, and you can see the naming pattern continues. The third term is called A3, the fourth term is called A4, and this last term here is called A, and I'm not sure yet what term this is, so I'm going to put a question mark here. So part of solving this problem is to determine what term 1024 is, so that we can find the sum of this geometric sequence. So because it's a geometric sequence, it has a common ratio. How do we get from 2 to 4? Well, 2 times 2 gives us 4. And how do we get from 4 to 8? We multiply by 2 to get the 8. And this pattern continues. 8 times 2 gives us 16. So for this particular sequence, the common ratio is 2, because you must multiply by 2 to get to the next term. You can also determine the common ratio using the equation R equals A2 divided by A1. A2 is 4 and A1 is 2. So 4 divided by 2 is 2. 2 is the common ratio. You can choose other terms as well. So for instance, A4 is in the numerator, so the previous term must be in the denominator. The previous term is A3. So we can also determine the common ratio by A4 divided by A3. So we have 16 divided by 8, and this equals 2, which is what we got here. So the common ratio is 2. Now again, we're trying to find what term 1024 is. To do this, we'll use the rule for the geometric sequence. This rule is AN equals A1 times R to the n minus 1 power. The nth term of a geometric sequence with A1 as its first term and R as the common ratio. So in this equation, n, if we solve for n, this will give us what term 1024 is. So let's do this. Let's put the information that we know into this equation. A1, that's the first term, that's 2. So we have 2 times the common ratio, which is 2, to the n minus 1 power, and this equals 1024. Again, we're trying to solve for n. So I'll divide by 2 on both sides. I get 2 to the n minus 1 power equals 512. And now I want you to think about the property that if two powers with the same base are equal, then their exponents must be equal. So if we have a number b to the x power, and this is equal to b to the y power, you can see that the bases are the same, and these numbers are equal to one another. Therefore, we can set the exponents equal to one another. And this rule is true as long as b is greater than 0 and b is not equal to 1. So we have 2 to the n minus 1 power, and what we want to do is determine 2 to what power here would give us 512. So 2 to the 10th power gives us 512. We have 2 to the n minus 1 equals 2 to the 10th power. Now we have the bases that are the same, So n minus 1 equals 10. What I've done is set the exponents equal to one another in this step. Now we solve for n. I'll add 1 on both sides, and I get n is equal to 11. So this means that A11, or the 11th term, equals 1024. So we know that there are 11 terms in this sequence. Now we want to find the sum of these 11 terms. To do this, I'll use the equation for the sum of a geometric series. This is Sn equals A1 times 1 minus r to the nth power divided by 1 minus r. Filling in what we know, the sum of the first 11 terms equals 2 times 1 minus 2 to the 11th over 1 minus 2. And when we simplify, we get 2 times 1 minus 2048 divided by -1. And this equals 2 times 2047, which equals 4094. So letter C is correct. The sum of the first 11 terms is 4094. Thanks for watching.